Hi everyone, for this question you say a function is given by this is your rational function. Show that for some constant AB means here is your number, your rational function can be expressed in this form. So firstly, observe your rational function. Is it your rational proper? Observe your fraction here. Is it proper or improper? Up here is linear. Down here also linear. Numerator linear. Denominator also linear. So they are having the same power, which means that this is an improper fraction. So improper fraction can be expressed in this by the concept of long division. Because improper fraction, when you do long division, it will give you quotient plus remainder over divisor. So that is the meaning for this question. Express your improper fraction to be a proper fraction. So to express that, we're doing our long division here. So firstly, our polynomial rearrange. Start with x, continue with constant. Denominator here, divisor also start with x and number. So what do you need here to get negative 1? You time negative 1. Negative 1 times x, you get negative x. So here you get negative 1. Finding your remainder. So this one minus you get 0, then you minus you get 4. Therefore, your 3 minus x, your polynomial, and your divisor 1 plus x. After you long division, quotient is negative 1 and remainder is 4. Divisor here is x plus 4. So that is the form that you have here. Alright, so this is shown into the form of proper. Question B, state the asymptote. So asymptote, we can look at the domain and range. Domain of this function, you can see domain of this function. So read from the proper fraction here, denominator not equals to 0. So not equals to negative 1, which means that vertical asymptote is happen at x equals to negative 1. So domain is read out your function. Domain on the left, value domain is the value of x that your function have. So your x is not equals to negative 1, then that negative 1 is your vertical asymptote. Meanwhile, if you want to know your horizontal asymptote, you can read from your range. So range of your function, you can see here range of the function. So domain, we look at DSLR. So rational, we really look at it. Find from your denominator what's the value is undefined. So that value undefined will be your vertical asymptote. So range will be causal, so rational. How to look at rational? We close the rational part. We close the fraction part. We can see negative 1. So for range, y not equals to negative 1. So that value will become your horizontal asymptote, which is y equals to negative 1. So just 2 marks. Read out from domain and range. Then question C, they ask us to show that the composite function f of x equals to x. So f of x. We substitute our fx here. 3 minus x, 1 plus x. Or you want to use the proper one, also can. Then we substitute again to your function. So substitute, look at your function here. So your function x here will be substitute by this fraction. So 3 minus something, 1 plus something. So substitute in. Now we have our question, fraction over fraction. So simplify this. To simplify this, we get same to the denominator. We have 1 plus x. So look at here. So this one times 1 plus x, so 3 will times 1 plus x. Then here is minus 3 plus x. So this is numerator fraction. Meanwhile, denominator, I spread it, divide by this denominator fraction. Okay, get same the denominator, so times 1 plus x. And we simplify it into the single fraction here. So here 3 minus 3, 0. X plus x, we get 2x. 1 plus x. Divide, we do it, multiply and reverse it, inverse it. So x minus x, 0. This is 4. 1 plus 3 is 4. And we can see 1 plus x multiply together can cancel. Here also can cancel. Alright, so some mistake here, that is not 2x, here is 4x. Alright, so 3x plus x, this is 4x. So 4 over 4, we cancel. Lastly, we get x only. Alright, so we get x only. So that's why we should be done from part C. So shown for all x less than -1. Then they say D, deduce your F inverse from part C. So from here, question D. So you have to alert here for question D. As you can see, F inverse equals F composite to the function, it get x, which means that this function is inverse to itself. Because F inverse get x. So your F inverse will directly equals to your Fx, which is 3 minus x, 1 plus x. So that's all. For this question, you cannot recalculate and show me how you get F inverse. Alright? Because it said you have to deduce from part C, you have to delete it from this composite concept here. Then question E, you're going to sketch this graph and state its range. So before we sketch this graph, we look at the domain and range, and you have to be alert here. This is a conditional function. So not the whole part of the graph is taking, they're only taking one part only. Alright, so we have vertical asymptote, horizontal asymptote, which is found, and we try to sketch it out. So question E. X-axis, y-axis label, and from the beginning of the questions, we know asymptote -1, y -1. So x equals to -1 and y equals to -1. And then look at our rational here. What is our shape here? Our rational shape basically got 2, which is 4 in quadrant 1, 1, 3, and 4 at quadrant 2, 4. So depends on your rational here. Look at your proper rational here. Your rational here is positive. So your rational positive, which means that it fall in quadrant 1 and 3. And your asymptote here is -1, x equals to -1, y equals to -1. And just now I remind you, the questions here, they're just taking one part of the function. So hanya sekerat saja graph yang tipe do, which is x less than -1. So which means that this part is not needed here. It's not stated in the domain and the condition for the questions. Therefore, our graph only having in the quadrant 3 here. And we label it as this is our function, 3 minus x, 1 plus x. And lastly, question said state its range. So state its range. So normally, just now what we find here, the range in general is y equals to -1. When we consider in together with the condition here, so you can see we only leaving one part here. Therefore, when you want to find your range now, you need to observe from your graph. So your range of the function when we leaving one part of the graph only. So from here we can show that range we observe it from the bottom. We start from -infinity going up until the horizontal asymptote here, which is -1. So it won't touch the horizontal asymptote, it will be open bracket. Alright, so then here we have labeled our 0 as origin. Now we see how to score this. So firstly, do the log division and express it in this form, 2 marks. So secondly, B just state, so we just need to see this vertical asymptote, horizontal asymptote, 1 mark. Answer for this directly 1 mark. Then showing the composite. So firstly, substitute into composite and show us how you simplify it, fraction over fraction until this x only. So this is your 3 marks. Then question D, they ask you to deduce only. So state out what's your f inverse. As long as you show it, this is equals to fx, then this is the answer. Lastly, E, sketch the graph and its range. So the graph here, firstly, is your shape. So only this shape, this is one. And then another one is for labeling. How many label that you should have in the graph here? Okay, let's just see. 1, 2, 3, 4, 5, 6. So your labeling here must be have 6. And lastly, state your answer of your range.